Okay, I think we are live. So, welcome everyone to the AEZ Quadratic Grant Round 6 demo sessions. We've had a few demos yesterday, and there'll be another session on Monday. But just a quick recap, we're kicking off round 6. Community voting, or the Macy vote, is live now. This is for round 6 of the grant. So, we've got a number of returning grantees and a couple of new projects in this cohort of grantees. It's great to be supporting public goods projects in the Cosmos ecosystem. And now is the time for the community to get involved. So just a quick recap on the prize pools. There are 8,000 Atom up for grabs, and that is part of the quadratic funding round. So you can vote with your Atom for the projects that you want to support, and then that will determine their ranking, and they'll get a share of that 8,000 Atom based on that ranking. And then concurrently is the Macy round, which anyone who's staking Atom on any validator is automatically whitelisted. So you can head over to dorahacks.io/AEZ, log in with your Kepler wallet, which you've used to stake Atom, and you'll be able to cast your votes using voice credits for the projects that you want to support from this cohort. So head over before the 3rd of May to support all of those projects. And we're going to hear from 3 projects today about what they are working on. We've got Chain Abstraction, we've got NiftyZK, and then a new project for the AEZ Cosmos upgrades. So we will kick off with Chain Abstraction. Cromston, how are you doing?
Hey, doing amazing. Thanks a lot for hosting a platform. Shall I go immediately to the presentation, start talking, or do
Yeah,
we have
start
like
sharing. I'll
yeah,
mute myself now, and the floor is yours.
yeah, let me turn on the camera as well and start sharing the screen. Yeah, let me know when you can see it.
Yeah, I can see it. Also, guys, just a quick pointer. If you can, at the start of your presentation, if you can do like a one sentence, very clear introduction to you and your project that we can then crop into the shorter videos afterwards, that'd be really useful. But yeah, we can see your screen, Cromson, and over to you.
Perfect. So I'm representing Megarock. We are like a small team focusing on consumer level applications on gaming on the sort of basically something that normal player users new people to crypto can uh, can be interested in. And the first problem we stumbled upon was that we're limited to small pool of Cosmos users specifically. That's why we start working on this abstraction problem to try to onboard users from other ecosystem. So we recently started created our Discord, so we can have all the info there, updates, and also on Telegram and other media. So if you want to keep updated or to recap everything that I'm not gonna say, you can head there. But yeah, it's we've been in DoraHacks since round 3 already, so it's been quite a few rounds. I think it's our 5th presentation already, and so far we iteratively we're building tools for achieving chain and account abstractions, and now we're at the level where it's already usable. Now we are focusing on UX issues, but let me hop to the presentation itself. So now I think it's round 7. Round 7 we're going to be focusing on new signers, and I'm going to explain real quick what it is. So what's the problem we're trying to fix first? What's chain abstraction? Imagine that this is your blockchain, and here's your virtual machine. Then virtual machine is basically where the smart contract lives and where all the most of the applications live. For example, Neutron on Cosmos Hub, this is where they are. And the way they work, you usually don't handle authentication and other stuff on your app. You just write your app, you write an NFT collection, you write your DeFi protocol over there, and you delegate the work to handle the authentication to basically to the code of the chain. And so far, our chains have been only supporting the Cosmos transactions. So you need to have the Cosmos wallet that can sign a transaction in a specific way so that our chains can validate it. It's not the case for all of the chains. I mean, the specific graph, for example, Injective support Ethereum transactions as well, and I think Solana too. And there's some of the app chains trying to fix these issues, trying to add general support. For example, Osmosis recently added smart contract or smart account module, and also Xion have the specific module for this sort of thing. But it's still work in progress, I'd say, for applications, how to integrate it into your app as an app developer. So and also I'm gonna go over later why it's not probably not the best idea to rely always on a chain team to handle everything for you, because a quick recap is probably that there's a lot of this new type of authentication algorithm coming up all the time. For example, there's Bitcoin wallets now that with ordinals and everything got a huge boom. So yeah, so how we're trying to solve it. So we came up with the most simple idea is to have browser wallets. We call them real layer wallets. Let me zoom out a little bit. So you would ask user for the credential they have, for example, like Kepler signature or like MetaMask signature or like passkey sign in button. Then in a browser, like there's going to be hidden Cosmos wallet that the user is not aware of that would sign the transaction Cosmos transactions for you. Then you would pass the checks of the blockchain, and then on a smart account on your app, you would validate it. So another option is you can have like smart accounts that would validate everything for you and then call your app. So like I guess the smart wallets are trying to fix this problem, such as like Vectis, like on in Ethereum ecosystem safe and everything. So but it's also like work in progress. So essentially we are building tools for developers to be able to do easily like any of those. So we build tools to get these signatures. It's not like really like these credentials. Like for example, passkey sign in like a credential. It's not that easy actually to do it, and then we provide tools to validate them on the blockchain. So if you want to build an app with a built-in authentication, we build tools to do it easily. And also if you want to create a new smart account, smart wallet, it's also like integrated. Like there's ton of talented teams that focusing on accounts themselves. For example, Abstract, they could like add authentication, and then we could also redirect users to use their app instead of like our minimalistic accounts. So like one example of also like building tools and libraries is like hard to demonstrate. That's why we're also building multiple apps ourselves. So one app is a proxy account. I can demonstrate it really quickly, I guess. So this is like the live version where you can also try it yourself. Here I created a new one just to be able to demonstrate. So here, imagine this is app on Neutron, and user doesn't have a Kepler wallet here, so it can connect to the website. And there's Kepler option, but it's Kepler as Ethereum, not Kepler as a Cosmos. But let's try MetaMask. I have some funds on MetaMask, and then I can assign a proof of ownership of this Ethereum wallet. Then I can use, for example, use a couple of dollars, uh, and then create an account and do an action on Neutron. For some reason, there's no routes here, which shouldn't be the case. All right, I'll do the demonstration for the creating of proxy accounts later. But like for example, here I already have a created account. Let me get my Neutron address. So I imagine the account creation can be like visualized as this. You would ask for signature, that's proof of ownership of Ethereum wallet. And then you ask them to talk to their native chain, in this case, like Base network. Then you would pass some funds, like a couple of dollars worth of ETH. It will go over IBC, over multiple chains, like over Osmosis and whatever. Then it will land on Neutron. And on Neutron, we'll create an account for this user. We'd give permission from this account to the browser wallet to use the funds from this account, and then you can actually do the action, all kind of actions from this wallet. But you'll always be prompted to use your Ethereum wallet instead of Cosmos one. So this is like app on Neutron that it's already has some funds. It's like account on Neutron. It has some funds, like in this case, a few Neutron, and then I can. Uh, refresh the page. I think there's clash between my sharing screen and or there's something with my internet. I'm not sure. Mm, yeah, could try withdraw. I actually withdraw all the funds, but almost all of them. But I think there should be still a little bit left, so I can. Let's do max. I have like few neutrons left in this account. So whenever I try to authorize, I'll get a pop-up with my MetaMask, because this only MetaMask control this smart account on Neutron. And here we get like pop-up with actions that we're about to do. Like we do like bank operation. We send some tokens to the addresses specified here. So this is for proxy accounts, and the other like tool we're building, or account that we're building ourselves, is token bound accounts. So in token bound accounts, we can create an NFT account linked to an NFT, and as an owner, we can control the credentials on this account and how do you want to authorize actions. For example, we can have like passkey authentication. So if we wish, we could authorize an action, for example, to stake some stars in this case, and then whenever we want to sign, we'll get a pop-up with a for the passkey. Or same with it, we can do it with the Ethereum wallet. Like, here's the authorization, and now we're loading until it goes through, and so on. So regarding our previous round, we were working on a session keys. So now, like, for every actions, if I want to stake some more, I need to sign up this pop-up every single time. So we're working on the session keys, and like, we're almost done. We need to like do some more testing and then like ship it. But these two apps, we're kind of building in public, so you'll be the first. You could use them to see like the changes live, so that you know what's going on. We have like some screens for controlling the credentials, like pgrams permissions, so we'll probably add it there. So keep yourself updated by following this too, or like join our Discord server. And what are we building on this new round? So as you can see, the pop-up in MetaMask look like this, and if normal Ethereum user like would see it, it'll probably scare me away. So the reason is, this is like the most simple way of the basic, really sort of ancient way of signing the messages. There has been like many new updates on how to sign the message, but like so far, like for example on Zion chain and everywhere on all Cosmos examples I've seen, this was the only supported way, like, supported like option. But they are like also more modern is the type data. So I don't know if you can see it from the screen, but like how the screens look, by this like look way more structurized than reading this one. So we want to add also ability for that to use this type of credentials and also verify them instead of this. And there's also a new type, it's quite recent, called sign in with Ethereum, new protocol. Basically, like, before we had to connect to website first, and then like you could sign messages. This is sort of new protocol where you could sign in and like sign into the connect and sign message at the same time. So like same thing on Solana. So like you just get one. We want to add support for these credentials as well. And also like Bitcoin wallets with the ordinals and everything. Was a huge boom with browser wallets for Bitcoin. So like Xverse, Unisat, like there's quite a few of them. So we also want to add support like for requesting these credentials and also verifying them on chain. Like there's a I think partially we have partial support. There's two ways to sign them. There's like normal, like Solana, and like normal like curve, like the one with support already, and there's like this protocol that they require. So you need to use this protocol to verify the messages. So that's probably it from our side. Let me know if you have any questions.
Awesome. Thanks, Cromston, and good to have you back in the AZ for round 6. I don't
Thank
think
you.
we have any live questions, or we're not taking live questions for this. So
Yeah,
thanks for your presentation.
right.
We'll
Thank
move
you.
over. Yeah, thank you so much. We'll move on to NiftyZK. Peter, how's it
Yeah,
going?
hi. Let me just quickly share my screen. Okay. So thank you for having me back. NiftyZK is a project to develop zero-knowledge proofs for CosmWasm ecosystem by defining the proof circuit logic in Circom and then exporting CosmWasm verifier contract. The latest release of NiftyZK adds support for sparse Merkle trees, and the documentation is updated with more entries. So to use NiftyZK, you go to the GitHub repository and you can install it with npm. It depends on Rust, Circom, and Node.js, so you need to have those installed, and you can install the specific version. It gives you tooling to scaffold Circom circuit for zero-knowledge proof-based logic. It helps you with powers of tau ceremonies, and you can compile the circuits and run phase 2 ceremonies, which are circuit specific. It supports GROT16 proving system with BM128 curve, and that one requires a phase 2 trusted setup. So it hosts a little website for you where people can contribute to the ceremony to help secure your circuits. You can finalize your circuits, export verification keys, and at the end you can generate a custom WASM verifier contract using different crypto libraries. So you have a lot of variation. You can decide if you want to use the Bellman or the ArcWorks Rust libraries for your verify contracts, and you can verify it. So the development roadmap is here in the repository, and we just completed sparse Merkle trees, which adds a lot of new functionality if you're building for identity systems, identity verification, privacy, or roll-ups or similar things like that. It will make your life much more easy to use NiftyZK because you don't have to set up the environment. Everything will be generated for you. It will create the circuits for you. It will write the tests for you, and everything will work out of the box. The roadmap includes adding more custom WASM templates in the future and supporting more curves like BLS 12381 or Plonk. Probably Plonk is the next. So if you go back, you can see the tutorials here that I'm adding for each new release. And this release contains sparse Merkle trees. Now, sparse Merkle trees are a type of data structure that efficiently stores key value pairs, where each leaf node contains a cryptographic hash of a key value pair, and non-leaf nodes contain concatenated hashes of their child nodes. And you can use sparse Merkle trees for inclusion proofs, exclusion, and insert, update, and delete proving. Previously, the Merkle tree implementation that you could use in NiftyZK was with fixed Merkle trees, where the insert update logic was not included in the proving system, and you could only test inclusion proofs. Now with this one, you can test for exclusion and and verify your inserts and updates. And to use this, you just download the application with npm and run NiftyZK init, and then you can select new options for creating sparse Merkle trees. They come with Edwards digital signatures in the template. And there are separate templates for inclusion, exclusion, and insert, update, delete. But they are very similar, but they are separate circuits, so you need to compile them separately. And it gives you tools for serialization in JavaScript, because when you're working with sparse Merkle trees, it uses circumlib.js and circumlib for the underlying implementation. And it gives you methods to serialize the SMT object in JS and work with it more easily. And helps you initialize sparse Merkle trees from serialized leaves and deserialize the leaves. So it gives you all these extra things in JavaScript and a streamlined way to mutate the trees. And then for the circuits, it will scaffold you a circuit that has multiple purpose, and it will give you examples for many things. You can select the hashing function when you create a circuit. So each circuit can have Poseidon, Pedersen, and other hashing functions. And you can see on the screen the circum code, which is one of the examples that can be scaffolded. And it will give you it's a signature verification scheme where you verify that the signer of the message is in a Merkle tree. So it gives you a message input. These are the sparse Merkle tree input signals for your circuit. Here are the EDDSA verification input signals. This is a message hasher, and the message hash is signed, so the signature is verified. The message hash, yeah, is the output of this hashing function, and it's it's verified. Then it computes a sort of an account abstraction address from the public keys, which are these parameters in the signature, and then uses this pub key hash to check if a value is included in the Merkle tree or not. And the FNC function is a signal that will tell you if the function you're testing for inclusion or exclusion, and there are some other parameters which are explained in the documentation. And your public variables are the message, root, if you test for inclusion or exclusion, and the value that needs to be in the Merkle tree. Now, a circuit like this will let you create, for example, an identity system where you have a verifier who does KYC off-chain and then saves the verified account's address in the Merkle tree. And then that account can sign a message, and then the message can be verified to be valid, and it can be also verified to be inside the Merkle tree. And so it works as a whitelist for access control, and it can be used as a for anonymity, for creating anonymous transactions when basically the address that signs the message is hidden. So the public information is that there was a message that is signed by an address that is included in the root, and basically the method of what is verified. And you can test for insert, update, delete, which is the circuit is very similar. So it's not included here, but basically you can check on chain if an insert into a Merkle tree is a valid insert, and that the new root that you have you're trying to save is derived from the previous one. It's also good for scaling because you can create really large Merkle trees with millions of entries, but they don't have to be committed on chain. This siblings input, which is hidden, is Merkle proof, and it can be arbitrarily large. That's set by these levels. So you can, for example, use this for a ZK rollup with a lot of transactions and check if a transaction has been included in that Merkle tree or not. Yeah, so it will give you multi-purpose circuits. The other tutorial will just explain anonymity sets and how you can create an anonymity set very easily with NiftyZK. So there are many different schemes to implement this. An anonymity set is a pattern that aggregates entities into a set such that they cannot be distinguished anymore. So each entity, it's verifiable that a signature is originating from a group, but you cannot tell which one of the members of the group have signed the message. And it's a group signature scheme. And you can create a group signature scheme with Merkle trees, with NiftyZK very easily. So you can select, in this example, it's an EDDSA signature verification with a fixed Merkle tree. And that will scaffold you a circuit where it looks quite similar to the other one, but this is not a sparse tree. It's a fixed size Merkle tree where a message signature is verified and checked if it's in the tree, if it's included in the tree. In that case, the anonymity set is the tree itself, which can have arbitrarily large leaves. So you can have an anonymity set of 1,000,000, but you still have very small proofs to prove that you are one in 1,000,000 who signed it, who has permission to sign it. And you can use this smart contract to implement a verifier to I'm sorry, to create shielded transactions or other anonymity schemes. This scaffold is very similar to what Tornado Cash uses. It's very similar to it, and you can use this to build private DAOs, confidential voting, private financial transactions, and things like that. So that's the update. This is the new feature, a new scaffolding, and then the next feature will be probably Plonk, which will be implemented in Rust. So there will be a Plonk-based Plonk verifier, and the build pipeline for the contracts will be for the circuits will be updated with Plonk support. And Plonk is going to help developers create circuits without doing a phase 2 ceremony. So Grot 16 requires a phase 2 ceremony setup, which has tooling included in this application to run. Plonk does not require this phase 2, so it allows developers to iterate faster on their contracts, on their circuits, and on their contract. And BLS 12381 curves are also on the roadmap. Currently, getting powers of tau files for BLS 12381 curve is more difficult. Powers of tau files are a trusted setup phase 1 ceremony files, which are reusable. And the application will download them for you. And the one used is from the Polygon Hermes ceremony. So it's very safe and verifiable to be secure. A BLS 12381 curve does not have these files. So ceremony has to be hosted and created with many participants to create that. And with these tools, you can build anything you want. Basically, it will help you get started very fast. That's it.
Brilliant. Thanks, Peter. And good to hear about your updates since the last round as well.
Okay.
So yeah, that's great. Feel free to stop sharing your screen and we'll move on to our final presentation for the day. This is a familiar face, but with a new project for us at the AEZ Quadratic grant. So Brian Labs, you may know from Warp CLI, but we've got a new project called Cosmos Upgrades. Sorry, hang on.
Cosmos SDK, but yeah.
I'm getting mixed up. We had another grantee also switch to a new project this round. I'll stop talking now. Hand over the floor to you, Dan.
Oh, awesome. Hey, thank you so much. And guys, I have a really cool app that I'm excited to show you. So if you're a validator, or if you care about your validators having nice tooling for keeping the chain secure, this is what I'm trying to solve. So chain upgrades right now in Cosmos, there's different levels of being notified of them. I believe what most people do is they watch Discord channels. They see things like, hey, Osmosis has an upgrade on this date, and then they'll go read about it, then they'll prep their infrastructure. As you know, upgrades get delayed sometimes because of the block speeds. So what I wrote last year was an API, which allows people to query to know when a chain upgrade is happening. So the first thing was I wrote this API, and when they run it, you can see there are different networks. There's Quorum, Ellis, Lava. So all these different networks, they have upgrades. We know the upgrade details. Then we estimate when the upgrade is going to happen. So this is kind of like V1 where we were last year with this API. I've always wanted to make this into like a GUI kind of web app product. And that's what I'm going to show you today. So Brian Labs is now presenting Cosmos Upgrades UI. All right, so what are we looking at here? So all of these chains right here are getting pulled in dynamically from the chain registry. The chain registry has probably about 300 plus chains defined between mainnets and testnets. We go through, we test every single one of them, find the RPCs, find the APIs that are healthy so that we can make these queries. If we can't find them, then we just run the infrastructure ourselves. This tool allows for private endpoints for when there's nothing in the chain registry. So what can you do with this? So it shows you the different chains and kind of the upgrades. I can say I want to see all the chains, or right now I just want to look at which ones have upgrades. So on every specific card, you'll see like a network identifier. If it's still in voting or if it's been passed, and it's definitely going to happen, what height the upgrade will happen at, and kind of a countdown. And then if you need to like link to the Explorer, you can just click on any one of these things and see more details. All right, but there's more. So there's a couple of hidden features on here. So you get to know if Cosmovisor support is built into the upgrade. So going back to the API, you can see there's this plan. So Cosmovisor requires that upgrades have plans with the binary and the checksum information. So that's one thing we do. We're also going to have it so that if you click this calendar icon, right now we don't have it in there, that it will add it to your calendar, whether it's like a ICS, Google Cal. And the coolest thing is if you click into any network, I got to connect my wallet. So that's another cool feature is it will connect to your wallet so you can have an identity. You can favorite the chains that you care about and say, hey, I only ever want to see my favorite chains. And then for my favorite chains, I want to know on Nibiru in Discord, or that's Slack, hooks.slack.com. And then I get to say what I want to be notified of, whether when there's something new proposed, when it's planned, or hey, I don't care about that. I just want to know when it's time to upgrade. I think that's what most people will do. So I like to do this. They're like, I want to be notified 8 hours before an upgrade in Slack so that I can get on and start working on preparing the upgrade. So now it's on there, webhook added, and then we'll have buttons for testing webhooks. But yeah, really that's what this tool is. It's just a really easy way for validators to keep track of chain upgrades. It supports currently 243 chains. So I'll kind of scroll through so you can see all these different ones that are in here. Yeah, and if you're a protocol team or anything and you want your chains to be featured, we're happy to work with you on that. If you have any feedback on the design or any features that you would like to see on here, please let me know. But yeah, that is our project. And if you like this, please consider going over to the DoraHacks page and voting for both Mackie and Adam donations. And we'd very much appreciate it. There's lots of dev work that we want to do, especially around the webhooks. And yeah, thank you so much.
Great. And great to have a new project from you guys as part of the AEZ. As Dan mentioned, you can go over right now and vote for any of the projects that you've seen today or from any of the other demo sessions. There are 11 grantees total. So you need to head over before the 3rd of May and you can cast either an Atom vote, like a donation to vote in the QF round or the Macy round, which has over 30,000 USDC total prize pool for this round. So big thanks to Cosmos Hub, AA DAO, and Dora Factory for contributing the funding for this program. It's great to be able to continuously support all of these projects. So yeah, head over before the 3rd of May and cast your votes. Dan, I wonder if we can get Dora Voter, the Cosmos app chain developed by Dora Factory, added to Cosmos upgrades. Is it there?
Definitely. So it's in the chain registry. There's no upgrades planned, but yeah, if when there is, it will be in there.
Awesome. Great.
Yeah, but yeah, let's definitely talk about like getting some logos put in the chain registry so that it will look very pretty.
For sure. Yeah, we can spice it up a bit. That'd be great. Okay. Anything else you want to add, Dan?
Nope. Just thank you guys. Yep.
Great. Okay.
Oh,
Yeah,
actually,
great.
sorry, I do have one more thing I want to add. Josh, my dev, is on the call here. He did a lot of the UI mockup stuff for me. And then also wanted to give a shout out to Peter, who wrote a lot of the API for me. He's not here right now, but I couldn't have done it without these guys.
Amazing. Thank you, Josh and
Thanks.
Peter. All right. And big thank you to other Peter from NiftyZK and Cromston for joining and giving their demonstrations today. We'll leave it there. The next demo is on Monday at 4 p.m. UTC, which is an hour later. You'll be able to see the final 1 or 2 grantees there. And then, yeah, head over before the 3rd of May to dorahacks.io/AEZ to cast your votes. Thank you, everyone. Thanks for joining, and thanks for everyone for tuning in at home and seeing what these brilliant projects are building.
Thanks a lot for the platform.
Yeah, thank you.
Awesome. Okay, see you next time.